A couple different methods can help you find the volume of a solid with circular cross-sections, like that of a cone. Start with the pancake method. Find the volume of the solid between x equals 2 and x equals 3. You get that by rotating the curve y equals e to the x power about the x-axis. The solid looks like this. If you think of the shape as a stack of very thin pancakes, you can find the total volume by adding the volumes of all the pancakes. Break it down. First, determine the area of any old cross-section, otherwise known as a representative pancake. Each cross-section is a circle with a radius of e to the x power. Its area is given by the formula for the area of a circle, a equals pi r squared. Plugging e to the x power into r gives you this. Next, tack on a dx. This actually represents the volume of an infinitely small thickness of this pancake. Now, add the pancake volumes from 2 to 3 by integrating. You substitute with u equals 2x and du equals 2dx and get 548 cubic units. Now, try the washer method. If your solid has a hollow area in the middle, you have to subtract for the hole in each slice. There's nothing to it. Here's an example. Take the area bounded by y equals x squared and y equals the square root of x and generate a solid by revolving the area around the x-axis. As you can see, you add the volumes of a lot of washer-shaped cutouts to find the volume of this solid. Here's how you determine the volume. First, determine where the two curves intersect. It takes very little trial and error to see that y equals x squared and y equals the square root of x intersect at x equals 0 and x equals 1. So, the solid in question spans the interval on the x-axis from 0 to 1. Next, figure the area of a thin cross-sectional washer. Each slice has the shape of a washer, so its area equals the area of the entire circle minus the area of the hole. The area of the circle minus the hole is pi times the radius of the large circle squared minus pi times the radius of the small circle squared. For this problem, the outer radius is r equals the square root of x, and the radius of the hole is r equals x squared. Now, multiply this area by the thickness to get the volume of a representative washer. dx is the thickness. Add the volumes of the paper-thin washers from 0 to 1 by integrating. Focus on the fact that the area of a washer is the area of the entire disk, pi times the outer radius squared, minus the area of the hole, pi times the inner radius squared. When you integrate, you get this equation. This is the same as this formula in most books. You're more likely to remember how to do these problems if you understand the big circle minus little circle idea.